This video will provide an overview of a new workflows feature for Oasys 21, EuroNCAP VTC videos. At Oasys, we've been working on new software features to support the upcoming virtual testing protocols, including the EuroNCAP Virtual Farside Simulation and Assessment Protocol. The new features to support virtual testing protocols are being built into the workflows framework introduced in Oasys 20. For more details on workflows, watch our Workflow Burst video or the 3-part webinar series. The EuroNCAP VTC Videos workflow tool helps you calculate the views and export the videos specified in section 5.2.1 of the EuroNCAP Virtual Farside Simulation and Assessment Protocol. The tool attempts to calculate the camera positions automatically based on model entities you define in Primer. You can then adjust and save the views to be reused to capture the videos for future LS-DYNA runs. You can set up the tool in Primer and then calculate and update the views and then export them as videos in D3plot. You can also automate the process in Reporter. First, let's look at the setup in Primer. Read in your model, then, in the Tools menu, click on Workflows. For ease of finding it, filter by Virtual Testing and then click EuroNCAP VTC Videos. Once the VTC Videos GUI opens, to begin, select the Virtual Testing Reference ID. If Other is selected, you can enter your own reference ID in the text box that will become active below. Next, using the drop-down, select the unit system of your model. There are various model entities that need selecting to aid camera positioning. You can click the question mark button to open this diagram that illustrates how the entities are used to orient the camera for each video. Press Select on the dummy parts by Include and either pick the Include file containing the dummy or use the selection menu in the top right and press Apply. Then select the parts for the left and right outer sled, which should contain the door frame. The following labels come from the WorldSid dummy manual for specific nodes. Hover over the label like so for more information. The head node and left and right lower thorax rib nodes are selected via database history node keywords. The left and right outboard knee load cells are selected via database history beam keywords. Next, the next step is to select 3 node IDs for a shifter form definition. This is a reference frame that holds the sled in position during the videos. So I'll go ahead and screen pick those 3 nodes. Once that's done, then using the radio buttons, select LHD or RHD for left or right hand drive vehicles. Please note this does affect camera positioning. As well as saving the user data file, you need to select a directory to save the property and cut section files that D3plot will use to define the camera positions. These can then be reused for subsequent LS-DYNA runs. To do this, click on the directory icon and select a file location in the Windows File Explorer. The last thing to do in Primer is save the workflow data to a JSON file, or you can save it to your model and then write the keyword file from Primer. Once you've done this, the next time you open up the workflow in Primer, your data will be automatically pre-populated. You can then start the post processor by clicking on Post in the top right and then Start D3plot. In D3plot, load in your model and then in the Tools menu, click on Workflows and then select EuroNCAP VTC Videos. The D3plot GUI is laid out to help you navigate through the process. Step 1 is to calculate the views. Use the checkboxes to control which views you wish to calculate. By default, these will all be set to checked. When you click Calculate View, the properties files are generated and saved in the directory you defined in Primer. Because we had the X section view selected, which uses cut sections and transparency, this window opens to confirm that they have both been switched off and the view that you are left with is not the X section view. Just press OK on this window. Once the views have been calculated, step 2 is to verify and update the views. Click the View buttons to see each view in turn. If you are not satisfied with the view calculated, you can manually adjust the view by moving the camera position. You can click the question mark button to remind yourself of what the view should look like according to the EuroNCAP specification. I was not satisfied with the front view, so I will click View Front, and now I'll go and make some changes, like so. Now I'll click on Update and Save Front as I'm satisfied with the new view. The same goes for Front Center, so I'll update that view too. The final step is to set the video quality using the slider between 10 and 100. According to the EuroNCAP specification, the video should be 1 to 10 megabytes in size. Export videos will export all 6 videos by default. You can change this via the drop-down, but I'll leave all 6 selected. Finally, click on Export Videos to export the video files to a directory that you select. Here are the output files produced by the tool. Hopefully, the tool helps you create the videos required by the EuroNCAP VTC protocol. If you have any questions or feedback, please contact us. Thank you.